Alrighty, let's do this. Partition array given according to given pivot. I previously solved it. Medium. Given 0 index integer array nums and integer pivot, rearrange nums such that the following conditions are satisfied. Every element less than the pivot appears before every element greater than the pivot. Right. Every element equal to pivot appears in between the elements less than or greater than pivot. In between the elements. Okay, yeah, so they're kind of grouped up. Relative order of the elements less than pivot and the elements greater than pivot is maintained. Relative order. Okay, I see, yeah. Return nums after the rearrangement. Looks like you can create a new space for it though. Doesn't have to be in place. Pivot is 10, so every element less than pivot appears before. Okay, so you want to push the 9 to the front, 12 to the back, 5 to the front. So it's like 9, 5, 3, 2 10s, 12, 14. Yep. -3 pivots 2, so -3, 2, 4, 3. Okay. I'm trying to figure out, so you probably want to have, I mean, I'm not sure why this is medium, unless there was some sort of space thing. Because I think you just do a couple of stacks. Right, you have a stack for stuff before the pivot, a stack of stuff that is after the pivot, and then kind of merge the stacks. So I'll say before is the array of stuff before, after, and then maybe a count of the number of times the pivot occurs. So for every value in nums, if the value is less than the pivot, then before appends it, else if the value is greater than the pivot, then the after appends it, else it's going to be a pivot. So add 1 to the count. I guess before is just the answer, right? So I think I can do something like, I guess, before dot extend, or is it extends? I think it's extend method, okay. Extends, you pass in an array, so it's going to be like pivot times the pivot count, the pivot as an array. I could also just do a list comprehension here. I'm not sure which one's faster. And then before extend by the after. I wonder if I can do this in place. Feels like I might be able to do this in place. No, whatever. This should be fairly fast. I'm not sure if it's the fastest way. Okay, I mean, it's pretty fast. And I guess maybe people aren't using extend for the other answers. I wonder if a list comprehension here is faster. I guess I can just ask. Is it faster to construct an array of duplicate values using list comprehension or multiplication in Python? List multiplication is significantly faster than list comprehension. Interesting, really. It creates independent objects. When multiplication is faster, you should use it for multiple. When multiplication is faster, you should not use it for mutable objects like lists or dictionaries. The danger of multiplication with lists, yeah. Yeah, you don't use it with references. Interesting, creates infinite objects. Okay, whatever. Anything else here that I mean, I guess maybe I don't actually need to do the count because I can just do the size of the before and after. And that might be faster. So maybe pivot count is just the length of the nums minus the before and minus after. Minus the length of before minus the length of after. So that's one less thing. I think I need closing parentheses, probably. Anything else I can do here? How is that slower, man? What? That has to be random. There's no way. There's no way that that's slower. Or there's no way that that should, in theory, be slower. Okay, 19. Randomly faster. Wonder. Can I do this in place somehow? Can I do this in place? Shuffle the things up. I think I might be able to do it in place. I think I might be able to do in place. But it would have to be 2 passes. It would have to be like a forward pass and a backwards pass. Okay, I'm gonna try it and see. This isn't actually in place, but this is maybe faster. Maybe this is just an alternative technique. I think maybe if I have an answer array that is pivot times the length of the nums array, so I just fill it with everything that's in the middle, kind of, and then I maybe use 2 pointers. So for, I guess maybe I should use, in this case I have to use an index, and that may be that might make it slow, to be honest. An index loop is generally slower than a for each value loop. But let's see how this goes. For every index k in range n, I'm gonna say I need a pointer, I guess. Actually, I can, I guess the for each loop going the front way is pretty fast. For every value in nums, I don't have to use an index loop. If so, let's say, what's going on? If p1 is equal to, let's say, I'll just call it pointer. So pointer is going to store where it's storing into the answer array. So for every value, if the value is less than pivot, then the answer array at the pointer index is equal to this value, and then increment the pointer. And then just do the reverse, but starting with the pointer at the back end. For every value, I wonder if this is actually faster. I can use an index loop going backwards. I can use or I can reverse nums. I guess it has to be faster to use an index loop at this point. For k in range, n minus 1 to -1, -1. So decrementing from the last index, if the value is greater than pivot, then answer at the pointer is equal to this value, where this value is num set k. Pointer decrements, and then I just return the answer at that point. I don't know if this is any faster though. I mean, it doesn't use extends, but it does use indexed arrays or indexed for loops. Okay, worth a shot. Didn't think it would be that bad. I guess the memory should be better. Whatever. Okay, I'm going back to this one. What was this? 19 milliseconds, right? Or 19 milliseconds in the fastest case. Probably gonna be whatever. Okay, whatever. Summary. This is pretty simple for a medium problem, especially if you're using a bunch of extra arrays / stacks / other data structures to store the information. I think it might be possible to do this in place, but they definitely didn't ask for it, right? Rearrange nums. Yeah, there's problems where they say explicitly that it has to be in place. And there's not even a hint to try to do this in place. Okay. Just keep arrays to temporarily store the values bigger and smaller than index. Can determine the number of times pivot occurs using math on the lengths of arrays, or keep track of count use the extend on the list to quickly combine arrays together. Not sure if the problem also intended to find a in-place kind of sorting. So, i.e. no extra arrays. But since it doesn't explicitly state it, I'm not bothering to try. Okay, time complexity, this should be O of n, where n equals the length of array. Since you're doing a single pass over all values and constant work within the for loop. And then space complexity, this is going to be O of n, since we're storing some temporary arrays. Actually, I guess it's just space temporary array for the stuff after the pivot. So yeah, keep it before array, keep it after array, add to them, and then use extend appropriately.